Okay, we are starting 11.2 today. 11.2 is our transformation of rational functions, rational functions, aka also known as reciprocal functions. Okay. A rational parent function is what we're going to start off with. So here we have our rational parent function. So a rational function is a function whose rules can be written as a ratio of two polynomials. So when you have a polynomial divided by a polynomial, you create a rational function. Basically, if you have an x in the denominator, you have a rational function. Okay. Its graph is a hyperbola, which has two separate branches. Okay. The rational functions may have asymptotes. So our asymptotes for our parent function are at x equals 0, and that is our vertical asymptote. And our other asymptote is at y equals 0, and that is our horizontal asymptote. Okay. So therefore, our domain, we have a split domain in range because of these two asymptotes. So our domain, we write it as from negative infinity to 0, union 0 to infinity. What this stands for is and. So we're taking a break. And this, so if we were to write this, and so this is our interval notation. If we were to write this as set notation, this little fancy braces, x, such that x, and if you want to write the words is a real number, or you can use this symbol that just stands for is a real number, and then the real number. But x does not equal 0. That is a mathematical sentence for you. So the same thing for our range, because it's split by the asymptote. We have from negative infinity to 0, break, 0 to infinity. That's interval notation. And our fancy set notation, we have y such that y is a real number, but y does not equal 0. Now, in your regular inequality notation, so if we were to write this as an inequality, we would just simply say that x is greater than 0 or x is less than 0. Inequality for range, we would say y is greater than 0 or y is less than 0. So all three of these are saying the same thing about the domain and range. It just depends on how the information is being given to you or what information is wanted from you. So again, we have our interval, we have our inequality, and we have our set notation. So we have interval, inequality, and set. All right, so now we're gonna talk about transformations. Yeah. Sliding on down to our transformation form. So for transformation, just like all our other transformations, if we have f of x, and we're looking and analyzing the function, in the numerator, we have our a. And as you can see, a is our vertical stretch and compression. Do we see that? So a is our vertical stretch and compression. If the absolute value of a is greater than 1, it's a vertical stretch. If the absolute value of a is between 0 and 1, it's a vertical compression. And if a itself is less than 0, then it's a reflection across the x-axis. Then we have our b. Our b is in the denominator. with our X. Our B is our horizontal stretch and compression, and it's the opposite of the vertical. If the absolute value of B is greater than 1, then it's a compression. If the absolute value of B is between 0 and 1, it's a horizontal stretch. And B causes us to reflect over the y-axis. So A affects, that's not how you spell effects. I wrote affecty. Don't know how. A affects our y's, and B affects our x's. All right, now we're gonna go on with our C. So we have bx minus c. So if we have a c value, our c value is our shift, is our horizontal movement, right? So c is our horizontal movement, and it affects our x's, because if we're going horizontally, that's our x values that are changing, right? And remember, our x is this is our liar. So if it looks like minus c, it actually is going to the right. If it looks like plus c, it's actually going to the left. And then finally is our D, and that's our vertical movement. Okay, our vertical is going to affect our, I don't know why I want to keep writing affecting. What is that? It affects our y's. And why lie? If it looks like it's plus D, I'm going up. If it looks like minus D, I'm going down. Another thing to note is what affects your asymptotes. Your D value, that affects your horizontal asymptote. Your C value affects your vertical asymptote. All right, questions, comments, or concerns? So what we're gonna do is we're gonna use this information to do several examples, and then that's it. We're gonna work a variety of examples using this information. Cool? Even if it's not, it's happening. Oh, keep it in mind before we leave here, our parent function table. So for our table, we're going to use our ones here. So we're at 1, 1, and we're at -1, -1. If you want to be more precise, you can use the fraction values. So for fractions, for example, we're at 2.5, and we're here at 1.5 and 2. But we can get a good sketch with just using our ones, if that's okay with y'all. Cool. All right. I'm going to apologize for right now. I should have put graphs on your paper, but I didn't. So you're going to have to sketch along with me, okay? I apologize again. So we're going to graph each function. We're going to identify the x and y intercept and asymptotes of the graph, and also state the domain and range of the function, okay? So when we are looking at what we have here, the variable that's given to us is our a, right? Because it's in the numerator. So we know a equals -2. And if we look at our table or think about our values of our parent function, we're at -1, -1, 1, 1. Which variable does a affect? The y. So to each one of my y values, I'm going to multiply by -2. That's going to give me +2 and -2. So now when I create my graph, I'm going to be at -1, 2. So at -1, +2. And I'm going to be at +1, -2. Because there is no change in my C and D value, guess what? My asymptotes do not change. So I still have an asymptotes at, I'm gonna be a little bit of a cheater. and draw my asymptotes with help. So I have an asymptote here, and I have an asymptote at here. So those are my boundary lines that I'm not going to cross. So I'm just going to sketch my graph following those asymptotes. So looking at my graph, I'm going to get as closest to 0 as I go, but I don't actually touch it. Boom, boom. I'm going to get close. I don't actually touch it. Boom, boom. Boom, boom. So I have a vertical asymptote at x equals 0. I have a horizontal asymptote at y equals 0. And because I have these asymptotes at 0, do I have intercepts? I can't have any intercepts, right? Because if I can't cross or touch the x and y axis, then there are no intercepts. So I have no intercepts. And my domain and range are pretty easy. So my domain is, I'm going to write it as inequalities. X is greater than 0 or x is less than 0. And my range is y is greater than 0 or y is less than 0. All right, we're going to do number 2 together, and then I'm going to let you do number 3. Okay? So on number 2, this time our A value is 4, right? A equals 4. So thinking about my parent function. And again, this could be done in your head, but when we're learning, it's good to write it out. So A affects my Y value. So to each one of my Y values, I'm multiplying by 4. So that gives me -4 and +4. So I'm going to sketch my graph and label what I know. My asymptotes were unchanged. So my asymptotes weren't affected. So I still have a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. And I'm going to plot my points. So I have -1, -4. So -1, and then we're going to come down here to -4. I have +1, +4. And I'm just going to follow the asymptotes. And again, do I have any intercepts? No intercepts, because I cannot cross my asymptotes. And my domain and range is still, this time I'm going to write it as set notation from -infinity to 0, 0 to infinity. And my range is -infinity to 0, 0 to infinity. All right, I'm going to pause. I'm going to let you do number 3 completely. Let's check and see what you did. How you wrote your domain and range is up to you. But I just wanted to make sure you saw all 3 different ways that the domain and range can be written. Remember, we have our inequalities, our set notation, and our interval notation. So overall, doable, awesome sauce. Okay, so based on what we did above, and based on your knowledge of transformation, without graphing, we're going to describe what A does to the graph. So what does the A value do without a graph? How is it going to affect our graph? All right. So here, because a equals -3, that is a vertical stretch by 3, and a what? And a reflection over which axis? Perfect. Boom, done without a calculator or a graph, right? All right, what happens with example 5? A equals 4. It's just a vertical stretch by 4. Perfect. All right, example 6, what happens? Perfect, reflection over x. And this time we have a vertical compression by 4. Cool? You feel comfortable being able to see the relationship without actually graphing it? Easy enough? All right, let's keep it going. Let's look at a couple more examples. So now we're going to talk about C and D. So what happens when we have our C and D variables? What's going to happen to our graph? How does it affect our domain and our range, and go from there? So starting with example 7, we have y equals 1 over x plus 2. And so 2 is what? What variable is given to us here? D. So we know D equals 2. And D affects which variable? Our x or our y? Our y. So if we have our parent functions are at -1, -1, 1, 1, to each one of them, to each one of our y's, we're going to add 2 because D affects our y values. So we end up with 1 and 3. D also affects our horizontal asymptote. Our horizontal asymptote is currently at y equals 0. But because D is 2, we have to add 2 to our horizontal asymptote. So our horizontal asymptote is now at y equals 2. So when we graph, we still have our vertical asymptote at x equals 0, but our horizontal is now at 2 because of that shift. So we're at x equals 0 and we're at y equals 2. And our points were at -1, 1. And we're at 1, 3. Bless you. So sketching it following our asymptotes. Bless you. And there it is. So it said to write our inequalities. Exactly. So we know that x has to be greater than 0 or x has to be less than 0. And y has to be greater than 2 or y has to be less than 2. How would you write it as what? You would write in set notation, you would write this, but you would write y doesn't equal 2 instead of 0. So it would be written as y braces y such that y is all real numbers, but y does not equal 2. Good question. All right, questions, comments, or concerns? Cool. All right, if this problem had asked us to find our intercept, I just want to point out really quick that if you need to find your x-intercept, because you actually have an x-intercept now, right? That means that you would plug in 0 for y and just solve for x. So if I needed to do that, I would do 0 equals 1 over x plus 2. That gives me negative 2 equals 1 over x. And we just have to reciprocate both sides, right? So we end up with x equals negative 1 over 2. And that's where my intercept would be. So it would be here, negative 1/2 comma 0. Okay? So you have the skills, the math skills to find your zeros without, again, using a calculator because you're the calculator. But if that comes up, remember, you're capable. All right, let's do 8. So on 8, we're given our C and our D. So we know that C equals 2 and D equals 3. And because of this, our parent function, we're changing both values, right? So we have negative 1, 1, and 1. Remember, we're going left and right, up and down. So it's not a stretch or a compression, so it's addition and subtraction. So we're adding 3 to our y's and we're adding 2 to our x's. So we're adding 3, adding 3, adding 2, adding 2. So now we're at 2, 4, and we're at 1, 3. And also remember, C and D control our asymptotes. So what our C and D are, those are our asymptotes. So if C is at equals 2, that means our vertical asymptote is at x equals 2. If D is at 3, that means our horizontal asymptote is at y equals 3. Mm-hmm. Perfect. All right, so I'm going to put in my asymptote. So I have an asymptote at, vertical asymptote at 2, horizontal asymptote at 3. So vertical at 2, horizontal at 3. And I'm roughly at 1, 2. So if I go to 1, go up to 2. And I'm here at 3, 4. So I'm going to go over to 3, go up to 4. And here's my sketchy sketch. Boom. So it asks for interval notation. So on here for interval notation, my domain, it starts at negative infinity and it goes up to 2, but then it stops and then continues to positive infinity. My range starts at negative infinity, goes up to 3, then it stops and then continues to positive infinity. If I had to find my x and y intercept, again, I would just be plugging in 0 for x and y and solving for the other. But it didn't ask for that, so we don't have to go that far. But did we see how C and D affect our asymptotes? Yes? Okay, cool. All right, last one. On the last one here, we have a lot happening. We have an A equals negative 10. We have our C equals negative 1. Remember, our x's is a liar. And we have our D equals negative 8. This for C or A? A is multiplication. you do PEMDAS first. You multiply and then you add and subtract. Okay. So we have X, Y. And so we have -1, -1. We have 1 and 1. To our Y's are being affected by A and D. So we're multiplying, change colors, sorry. We're multiplying by -10 and we're subtracting 8. Does that make sense? So to each Y value, we multiply by -10, subtract 8. Multiply by -10, subtract 8. That gives us 10 minus 8 is 2. That gives us -10 minus 8, which is -18. To our Y values, we're subtracting 1. I mean, to our X values, we're subtracting 1. So -1, -1. That puts us at -2 and 0. So graphically, I know that my asymptotes have changed. How do I know my asymptotes have changed? Because my C and my D are different, right? So my vertical asymptote is now at -1. My horizontal asymptote is now at -8. So at -1 and down here at, we're gonna have to count by 2s on here. 2, 4, 6, 8, 10, 12, 14, 16, 18. So we're counting by 2s. We can have -18. 2, 4, 6, 8, 10, 12, 14, 16. Again, counting by 2s. We're good on this. All right. So asymptotes going in. So I have an asymptote at -8. Horizontal, 2, 4, 6, 8. Who do we appreciate? And then I have a vertical asymptote at -1. Pretend that these are all super straight. And then my points that I'm going to use are -2 and +2. So at -2 and +2, I went above. I'm just going to follow my asymptotes. And then I'm at 0 and -18. So 0, -18. And follow my asymptotes. So you see I control my scale on my y-axis so that I could include the value, which is kind of an important value because it's also my y-intercept. All right, so set notation for this. So writing my domain in set notation would be braces x such that x is all real numbers, but x cannot equal what? -1. And then my y such that y is all real numbers, but y cannot equal -8. Questions? Do you see how they all three came together? All right. Let's scroll on down. Now, what if we are just given the A value and it wants us to, in the asymptotes, and they just want us to create the equation? Is that doable? It is totally doable. And that's because if we remember that our asymptotes, so it tells me here you're given asymptotes, right? And our asymptotes represent which two variables? They represent our transformation variables are C and D, right? They represent C and D. So our vertical asymptote represents, so x equals 0, that's our vertical asymptote, and that represents our C value. Y equals something, y equals 2 here is our horizontal asymptote, and that represents our D value. And they're giving us the function to start with. So they're telling us our A for each one of these is going to be 3. So I have A, C, and D. Can I make a function? Can I write an equation? Why, yes, I can. So I know Y equals, my A is 3, my C is 0. I'm going to write it just so you can see it. So I have X minus 0, and my D is 2. So my equation is Y equals 3 over X plus 2. So from here, I know that this graph has a vertical stretch and a vertical shift by 2, up 2. Agreed? All right, so let's do the next one. Again, your X is your vertical asymptote and your C value. Your Y is your horizontal asymptote and your D value. And it already told us our A. So what is our equation? Y equals A, which is 3, X minus my C, which is negative 2, plus my D, which is 4. So we have Y equals 3 over X plus 2 plus 4. So vertical stretch 3, we're going to go left 2 and up 4. All right, I'm going to pause and let you do the last one. All right, so let's see how you did. So your C, your vertical asymptote, is at 5. Your D, your horizontal asymptote, is at negative 3. So you should have Y equals 3 over X minus 5 minus 3. How do we do? Good? All right, that concludes 11.2.